Okay, so next topic that we're going to see is symmetric matrix. We have already studied in the previous topics about transpose of a matrix. So this topic is basically related to a previous topic, transpose. And first of all, let me define what is symmetric matrix. So any matrix of okay, first of all, it should be a square matrix and it can be of any order. So any square matrix can be symmetric, can be called symmetric if and only if its transpose is equal to the same matrix. So if I'm transposing a matrix and I'm getting the same matrix again, then that matrix is called symmetric matrix. Okay, so let me give you an example. So let's say I have a matrix 1 2 2 1. Okay, so if I write a matrix something like this, and if I'm taking a transpose, so if you can see the things which are going to be there in row, it will come in column here, and then again this will come as 2 1, right? So as you can see, the matrix and its transpose both are coming exactly same. So such kind of matrix are called symmetric matrix. So you might have got the idea that a symmetric matrix usually looks something like this, or I should write the general representation of symmetric matrix here. So any matrix of the form A, B, C, so diagonal elements can be anything, but whatever is here, the same element should be here. Whatever is here, the same element should be here, and whatever is there here, the same element should be here. So this is the general representation of a symmetric matrix. So symmetric matrix generally looks like this. So since if I take its transpose, so whatever is there in row, that will come in column. So AHG again will come here, sorry, it will come AHG, then HBF will come here, so HB, sorry, F, and then again GFC will come here as GFC, right? So as you can see, the matrix itself and its transpose, they all are exactly same. So the general representation of any 3x3 matrix which is symmetric is usually like this. And if I'm asking about a 2x2 matrix, then its general representation is AB, and here if it is C, then even here it should be C, like in this example what you had seen, that these two elements can be anything, it doesn't matter, but these two elements should be exactly same if I'm talking about a 2x2 symmetric matrix. Okay, so basically symmetric matrix is any matrix that if we transpose, we are going to get the same matrix again. Okay, now let me talk about the next matrix, that is skew symmetric matrix. Skew symmetric matrix. So what is skew symmetric matrix? Exactly like in previous topic, symmetric matrix, whenever we take transpose of any matrix and we are getting the negative of that matrix, then I can say that that matrix is skew symmetric. So let me take example of this also. So let me say 0, -2, 2 and 0. Okay, so let this be a matrix. Suppose if I take transpose of this matrix, so what will come here is, so 0 -2 is here, so it will come 0 -2, and then 2 0 will come here like this. Now if I take minus sign common from these elements, so if I'm taking minus sign common from these elements, so 0 will be as it is, this will be -2, this will be 2, and this will be 0 again. So as you can see, this was my previous matrix. So I'm getting A transpose as negative of the given matrix. So whenever this happens, then I can say that the given matrix, this was a skew symmetric matrix. Okay, now I'll tell you the general representation of a skew symmetric matrix. So a skew symmetric matrix of order 3x3 is always represented by 0 0 0 H G F minus H minus G minus F. So as you can see that whenever you'll replace the rows into columns, so whatever was here in plus, you'll get the same thing in minus here, and then when you take minus sign common, you'll get the exact answer. So this is general representation of a skew symmetric matrix, where the compulsory condition is only that the diagonal elements, they all should be 0, so that when we interchange them, or I can say that when we write its transpose, so we need not worry about these elements because they may cause problems here. Okay, now this problem was not there here because the transpose was coming exactly same, so it wasn't mattering there. Okay, so let us go to few questions and then we'll complete this. Okay, so given is a matrix 1 minus 1 5, then again minus 1 2 1, and then 5 1 3. Okay, this is the given matrix and we have to find its symmetric matrix. Okay, so let me tell you a theory first, its concept first, and then we'll go to this question. So for any matrix, let me take another page. Okay, so for any matrix A, okay, whenever for any matrix, okay, the condition is it should be a square matrix. Okay, for any square matrix A, any property that we're going to see, whether it was multiplication doesn't have this property, but for transpose or for symmetric and skew symmetric, the matrix that we are going to deal with, those are square matrix. Okay, so you have to keep in mind that the only matrix that we're going to deal with is square matrix. Okay, so the first I'll write point here. This is given as theory or theorem in your NCERT textbook. So for any square matrix A plus A transpose always gives a symmetric matrix, and A minus A transpose always gives skew symmetric matrix. Okay, so what exactly do we mean by this? Let's study with an example. Okay, so let me take any matrix, any square matrix will be fine. So 1 2 minus 1 0 3 4 1 minus 4 2. You can take any matrix of which is there in your mind. This will work in any square matrix. Okay, so this is a square matrix of order 3 cross 3. Now let me find its transpose first. Okay, so whatever is there in row, I'll write in column. So 1 2 minus 1, then 0 3 4, and then 1 minus 4 2. Okay, so this is my transpose. Now when I'll add these two, when I'll find A plus A transpose, so what I'll get is 1 plus 1, that is 2, 2 plus 0, that is 2, minus 1 plus 1, that is 0. Okay, 0 plus 2, that is 2, 3 plus 3 6, 4 plus 4 is 0, 1 minus 1 is again 0, minus 4 plus 4 is again 0, and 2 plus 2 is 4, right? So this is a matrix, as you all already know that symmetric matrix looks like A B C H G F H G F, right? So these elements and these elements should always be same, so that whenever I transpose this matrix, I'm going to get the exact matrix again, right? I'm going to get the same matrix, right? I'll just write this. Okay, so I'm going to get the same matrix again, so that is why this is called symmetric matrix. Okay, let me also find A minus A transpose here. Okay, so what I'll do is I'll simply subtract the corresponding terms here. Okay, so 1 minus 1, I'm getting 0, then 2 minus 0, I'm getting 2, minus 1 plus 1, minus 1 minus 1, I'm getting minus 2, then 0 minus 2, I'm getting minus 2, then 3 minus 3, I'm getting 0, 4 minus minus 4, so that, okay, 4 plus 4, it's 8, then 1 minus minus 1, so that will be 2 again, then again minus 4, so that will be minus 8, and then again 2 minus 2 is 0. So as you already know, this is exactly like 0 0 0 H G F minus H minus G minus F, which was the general representation for skew symmetric matrix, and this is exactly like A B C H G F H G F, which was general representation for symmetric matrix. So whenever any matrix, you are given any matrix which is square, then you find its transpose and you add them, you'll get a symmetric matrix, and you find its transpose and subtract them, you'll get a skew symmetric matrix. This is very important. In the last 4 or 5 years, questions for the symmetric and skew symmetric matrix were not coming, but before that, like before 2015, this was one of the major questions that used to come in exam. Okay, so let me take another example, or I should say let me go to next theory part. Okay, I'll write the second theory, theory 2. Okay, so what theory 2 says is, for any square matrix, I'll write its name also, for any square matrix A, okay, it can always be expressed, as sum of symmetric and skew symmetric matrix. And how can it be expressed? As we already know that A can be expressed as half A plus A transpose, this is our symmetric matrix, plus half A minus A transpose. So this is the general representation of any matrix in the form of a symmetric and skew symmetric matrix. So you can represent a matrix in the form of symmetric and skew symmetric matrix, and as a sum of symmetric and skew symmetric matrix. Okay, so in exam questions may come based on this. So what kind of questions can come is, let me take one question. So express a matrix is given here: 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. Okay, so express this as sum of symmetric and skew symmetric matrix. Okay, I'm writing it in short form, skew symmetric matrix. Okay, so what you have to do here is, you have to express the given matrix as sum of symmetric and skew symmetric matrix. So I already know that if I have been given a matrix, I have to denote it with some capital letter, and then the first thing to find symmetric or skew symmetric is finding the transpose of given matrix. So what I'll do is, whatever is there in row, I'll write it in columns: minus 2 3 minus 1, and then 2 minus 1 3. Okay, and then when I'll add these two, whenever I find A plus A transpose, let me denote it by some capital letter P. Okay, so when I'll add these two and take half of this. Okay, now let me first tell you the basic idea behind taking half here. Okay, so when I'll simplify this, so as you already know that whenever I multiply a matrix with a constant, it is multiplied with all the elements, corresponding elements inside it. So when I'll multiply these two, so that becomes half of A, and then if I'll multiply this with this, so this is half of A transpose, plus, so this plus will come, and then half of A, and then again minus half of A transpose. So this half A transpose, the half A transpose cancels each other, and then half of A and half of A becomes A, so that it comes exactly equal to this A. So this A and this A, so it comes same, right? So that is how we can equate symmetric and skew symmetric matrix to the given matrix. Okay, so let's move forward. So how to find A plus A transpose? It's basically again a 3 cross 3 matrix, and we have to add these two matrices, right? So 6 plus 6 is 12, minus 2 is minus 4, 2 plus 2 is 4, minus 2 minus 4, 6 minus 2, 4 minus 2, and 6 again. right? So this is there, and since you already know that minus 4 minus 4 4 4 minus 2 minus 2, and these elements can be anything, so this is a symmetric matrix. Let me write another matrix here. Let me denote it with Q, and that I'll find half A minus A transpose. Okay, so I'll write it half here, and then what I'll write is I'll subtract these two. Okay, so what I'll do is I'll subtract these two matrix. So it's 6 minus 6 is going to be 0, minus 2 is minus 4, 2 minus 2 is again 0, minus 2 is again minus 4, and okay, minus 2 minus minus 2, so it's plus 4. Just a minute. Okay, yeah, even this is minus 2 plus minus 2. Okay, that is fine. Then 3 minus 3 is again 0, then minus 1 minus to plus 1, so again 0, and then 2 minus 2 is 0 here, minus 1 minus minus 1, so plus 1 is again 0 here, and then 3 minus 3 is again 0. So as you can see, these all elements are 0. This is exactly negative of this, and these two doesn't matter here because they're already 0. Okay, and what I have to do is to show as a sum of symmetric and skew symmetric matrix, what I have to do is I'll have to add this half A plus A transpose and half A minus A transpose, that is I have to add P plus Q, right? So whenever I'll add P plus Q, I should get the exact given matrix again. Okay, so P plus Q I'll do. Okay, so for P plus Q, what I have to do is I have to find addition of these two matrices. So half, I'll take common half from both of these matrices. I can do that, and then I'll simply add these two matrices. Okay, P plus Q I have to do. So 12 plus 0 is 12, minus 4 plus minus 4 is minus 8. Okay, 4 plus 0 is 4, minus 4 plus 4 is 0, and just a minute, minus 4 plus 4, yeah, it's 0. 6 plus 0 is 6, minus 2, 0 is minus 2, then 4 plus 0 is 4, minus 2 is minus 2, 6 plus 0 is again 6. Okay, yeah, just this element is I think minus 4 plus 4, it's somewhat mistaken. Let me check here again what mistake I've done here. So A plus A transpose, so minus 4, no, here it's correct. What about here? So if there is minus 4, I should be writing 4, yeah, it's correct. Minus 4 plus 4, yeah, it's fine, it's correct. Okay, now if I'll multiply half here, so what I'll get is I'll get half of 12, half of minus 8, then half of this, then again half of 0, that is 0 again, then 3, then minus 1, it's again 2. Okay, so what we did here is a mistake. So when we are subtracting these two, so minus 2 plus, it shouldn't be plus, it should be minus 2 minus minus 2, so minus 2 plus 2, that is not 4, this is 0, and again here again minus 2 and plus minus minus 2, so that again becomes 0, so even this is 0, so all the elements inside this matrix were 0, so there we were doing a mistake. So if I'll add these two now, so now this will be minus 4, and I think mistake was done here, so 12 minus 4, 4, exactly whatever matrix is this, that will come here, so 6 minus 2, 4 minus 2, 6, and then if I'll multiply it with half, each element with half, so half into minus 4 is minus 2, so 6 minus 2, 2, and then this won't be 0, this will be minus 2 again, 3 minus 1, then 2 minus 1, and then 3. So as you can see that our given matrix here, that is 6 minus 2, 2, then again minus 2, 3 minus 1, and 2 minus 1 3, so these two are coming exactly same. So this is how you have to represent, or you have to express a given matrix as sum of symmetric and skew symmetric matrix. What you have to do is you have to find transpose, then add these two the matrix with transpose, take half of it, then again find A minus A transpose and take half of it, and whatever is coming in these two you have to add them, and whatever the answer you're getting, that should be equal to the given matrix. If you are able to express the given matrix like this matrix as the given matrix, then you have already shown that the given matrix is sum of symmetric and skew symmetric matrix. Okay, now let me move on